Hi guys, and welcome to the latest chemistry video on the chemical earth. In this video we're going to look at compounds. Compounds which are one of the groups of pure substances along with elements, but compounds can be broken down chemically into simpler substances. So the first thing we need to do is just to have a little bit of a look at the broad definitions of compounds. As I mentioned, compounds are pure substances and they consist of two or more elements in a fixed ratio. And this is what distinguishes them from mixtures. Mixtures may well contain two or more elements, but the ratios are not fixed. So for an example, an alloy is a mixture because the ratio of elements in the alloy can vary, but a compound is always a consistent ratio. So the water molecule H2O always contains two hydrogens for every one oxygen, a fixed ratio of 2 to 1. Because we have around 118 different known elements, the potential possibilities of compounds is almost endless, and we have a really large range of different compounds. For this reason, we tend to split them into different groups just to make them a little bit easier to study. Some of the important features of compounds is that they firstly obey the law of constant composition, and that's what I mentioned before about something like the water molecule. Water has a constant composition, 2 hydrogens to every 1 oxygen. Sodium chloride, common table salt, has 1 sodium for each chlorine, and so on. Compounds can be chemically decomposed into their constituent elements. Sometimes they can be decomposed into simpler compounds. So for example, something like water can be decomposed electrically into hydrogen gas and oxygen gas. And of course, if we were going to write this equation, we'd want to balance it. Whereas something like copper carbonate, for example, which may have been the substance you looked at last year, can be broken down into copper oxide and carbon dioxide. So both of these are examples of decomposition reactions where we take one compound and we break it into either its component elements or into two slightly simpler compounds. And of course, compounds can also be synthesized from their constituent elements. So decomposition is the breakdown of a compound into its elements, and synthesis is the recombination of elements to form the compound. Because there's such a wide variety of compounds, there are obviously going to be a very large number of different properties as well. But like we looked at in the previous video, the properties of compounds link to their uses. Or if you prefer, the use that we make of different compounds is dependent on their chemical and physical properties. The other thing that's important to be aware of is that a compound will have different properties to its constituent elements. Those elements will help to determine the properties, but they will not define the properties. So that is to say that if we have something like sodium, which is a very reactive metal at room temperature, and chlorine, which is a gas, at room temperature, and we combine these together to form sodium chloride. Sodium chloride is a solid at room temperature. It forms crystal structures, the common table salt. There are certain properties associated with common table salt that are very different from chlorine gas and from the sodium metal, but these elements help to determine the actual chemical nature and physical properties of sodium chloride. The other thing that's important to remember is that the properties of compound are constant whatever the source, however they are created. We may combine hydrogen gas and oxygen gas to form water. But likewise, we may combine an acid and a base to form a salt and water. Water is the compound in each of these cases, and that the properties of the water molecules will be identical in either situation. So no matter how we produce our compound, its properties will be consistent. So here's a question. How could you tell the difference between a mixture of iron and sulfur and the compound iron sulfide? Thanks for watching.